So this is the last section in the unit, and in this section we basically talk about the different proportional parts. So in the whole unit we've been talking about how sides of triangles are proportional to one another when the triangles are similar. So we have the same situation here, except we have other characteristics. So if the triangles are similar, then the proportional perimeters theorem says that the perimeters are proportional. So notice in these two triangles, we have that the two triangles are similar, and so we want to find the perimeter of the smaller one. The problem is we only have one of the sides. So one solution would be to find the other two sides using the proportional, the scale factor. So we can find the proportion of the sides and then find LM, NM, add up all three sides. That's one option. But like many of the other ways, that's a long way. That's more work than is needed because we can find the perimeter of this triangle and use the scale factor. So given the sides that we see that the scale factor is 12 to 5. The perimeters will follow this scale factor. So the perimeter for this larger triangle here is going to be 12 plus 35 plus 37, which is 84. So 12 to 5 is the same as 84 to the perimeter of the smaller triangle. So all we have to do is to find this product. So 12p is equal to 5 times 84, which is 420. And so we can divide that 420 by 12 to get that the perimeter of the smaller triangle is 35. That's it. There was no need to find these two sides and then to add them all up. We just use that same scale factor and use it with the perimeters. So here are some new theorems, some new ideas. And so basically, I'll just go through the shortcuts of these. These are right from the textbook. They get a little bit wordy. But basically, if you have two triangles that are similar, the measures of the altitudes are proportional. So if we have triangles that are similar, so here we go, two similar triangles, we already know that the sides are proportional, but the altitudes are also proportional. The altitudes follow that same scale factor. For triangles that are similar, angle bisectors also follow that same scale factor. The angle bisectors are proportional. And then finally, the medians are also proportional to that same scale factor. So whereas before we said, all right, we have similar triangles, all these sides are proportional. Well, now we know the sides are proportional, and to that same scale factor, the altitudes, the angle bisectors, and the medians all follow that same proportion. That's all this is saying. So some example problems, such as this one, we see that BG is a median and EH is a median. So we want to find EH if we know that BC is 30, BG is 15, and EF is also 15. Well, we can see that BC is proportional to EF. So the scale factor there is 30 to 15, which is the same as 2 to 1. So that is the scale factor. 2 to 1, that is the scale factor from this top triangle to the bottom one. So that is going to be the same ratio of the medians. So 15 to x. So that means that 2x is equal to 15, or x is equal to 7.5. So EH is equal to 7.5. That's it. So we treat this median just as we would another side of the triangle. Now, another theorem is the angle bisector theorem, which says that if you have an angle bisector, then it separates the triangle, or, well, an angle bisector separates the opposite side into segments that have the same ratio as the other two sides. Wordy, right? Well, going off this picture, we can see that CD is the angle bisector. Cuts this angle C into two equal halves. So AD to DB is going to be the same as AC to BC. So AD to DB, AC to BC. So side to side, side to side. So if we have, thrown out numbers there, 3 to 6, we can see that's the same as 1/2, then that would be 5 to 10. AD to DB is the same as AC to BC, same proportion, same scale factor. So let's look at some of these. So here we actually have a median. Notice this is a midpoint to the vertex. So the scale factor from the large one to the small one is 36 to 18, and from the large median is 20 to x. Well, so that's going to be 2 to 1 is equal to 20 to x. So we get that x is equal to 10. Here we have an angle bisector this time. We can see that these are congruent there. So the angle bisector, just as we have shown in the previous step, the angle bisector is going to be following that same proportion. So from the large one to the small one, we get 9 to 6 is equal to 12 to x. We can reduce this to 3 to 2 is equal to 12 to x. So we get 3x is equal to 24, or that x is equal to 8. Over here we have an altitude. We know that altitude follows the same proportion. So 4 to 3 is equal to 3 to x. So we get 4x is equal to 9, or x is equal to 9/4. 9. And here, actually, this dotted line is the altitude. Shows that height there. So we can see that 7 to x. That is equal to, so 7 to x is equal to 8 to 10. So 70 is equal to 8x. 7 to x is equal to 8 to 10. Yep. So 70 divided by 8, that's just 35 over 4. So we get some fractions there. That's okay. And so that's it. So just understanding now that we started the unit talking about similar triangles having proportional sides. Now they also have really all characteristics being proportional. So angle bisectors, medians, and altitudes all follow that same proportion, that same scale factor.